This is question number 11 of homework 5. The demand curve and the supply curve for 1-year discount bonds with a face value of $1,030 are represented by the following equations. So B superscript D, that stands for the demand curve. Price equals negative 0.8, quantity plus $1,160. This question is actually an extension of question number 10. So similar to that question, you have a negative sign here for the demand curve. So that's because we have a downward sloping curve for the demand curve, and the supply curve here is price equals quantity plus 710. So you have a positive coefficient here, which is 1, and that's because the supply curve is positive sloped or upward sloping. Suppose that as a result of monetary policy actions, the Federal Reserve sells 100 bonds and it holds. Assume that bond demand and the money demand are held constant. Which of the following statements is true? So if you look at these 4 choices, let's read the first one. If the Fed decreases the supply of bonds in the market by 100 at any given price, the bond supply equation will become price equals quantity plus 790. So basically, the second part of these 4 choices are all about bond supply equations, but they are all different. And the first part is whether Fed decreases or increases the supply of bonds. So the setup says the Federal Reserve sells 100 bonds that it holds. So when the Federal Reserve sells the bonds in the market, so that means the supply of the bonds should increase by that amount, by supply. So that immediately rules out A and B. Because A and B says Fed decreases the supply, but they should increase. The increase of the supply by 100. Both C and D meet that requirement. So now we should go to the second part. So if the Fed increases the supply by 100 bonds, should I just plus 100 here? We may be tempted to do so because that's straightforward and simple, right? But if you do that, actually that's incorrect, because notice the left-hand side here is price. So if you add 100 on the right-hand side, you are actually increasing the price by 100. And that's obviously not what this condition says. So how can you change the supply equation here and meet this requirement of increasing the supply by 100? We should, once we have an equation with the quantity expressed in terms of price, then we can add to that expression by 100, and that's increasing the quantity by 100. Right, so how can you have an expression for quantity? It's very simple. Based on this supply equation, you can just move this 710 to the other side, and then quantity will equal price minus 710. So once you have that, let me write down that. First, this is the supply curve. B superscript S, P equals Q plus 710. So you can move that 710 to the other side and change sides. So now the supply equation will become P minus. Once you move this number to the other side, you have to change the sign, 710. So now you can add 100 to the right hand side. So the Q, this is the new, equals Qn equals P, let me use N2, minus 710 plus 100, so that gives me 610. So then if you look at these four choices, it's still, the supply equation is still expressed for price in terms of quantity. So now we can just move this back. So price and move this 610 to the other side and change sides again. Pn equals Qn plus 610. So that you can see, compared to the original equation here, this equation, this is the new supply curve. Actually, you don't add to 710, you subtract from that 710 to arrive, subtract 100 from that to arrive at 610. So then we should choose D here, right? So then go on, calculate the effect on the equilibrium interest rate in this market as a result of the Federal Reserve action. So in order to know the effect on the equilibrium interest rate in the market, we have to know the original equilibrium interest rate and the new equilibrium interest rate. So then we can see how much that interest rate changes, and that's the effect on the equilibrium interest rate. So based on the solution to question number 10, you should be clear about how to solve out basically these two equations, two unknown system, to get the price, equilibrium price, and based on the equilibrium price, what is the equilibrium interest rate, right? We can solve out that. So this question here is slightly more complicated because now we have to solve twice, basically these two unknown two equation system to get the final answer. But the steps are exactly the same as question number 10. So for that reason, I guess I just skip this second part. And if you want to find out the answers, you can just follow the steps which I did for question number 10 and apply those steps to question number 11, but do twice the calculations as we did in number 10. And then once you get the equilibrium price, calculate the return on this 1-year discount bonds by following the same step as we did there, and that return is the equilibrium interest rate. And then you can just compare how much the expected interest rate on 1-year discount bonds will increase, decrease, or does not change to what. So that for that reason, I just stop here.